Electrolytes have different concentrations depending upon where you're looking for them in the body. So notice that these electrolytes here, if you can see this, these are charged particles. So cations, positively charged, and a couple of anions, including chloride and the bicarbonate ion. And so when we look at the difference, we could look at the extracellular fluid, which in this case is the fluid that is found in the interstitial and the blood plasma. So when we look at ECF, the things that we find that are more concentrated in the ECF are sodium. So notice this concentration, the together, right? Highly concentrated. The yellow is inside of the cell. So it is at a lower concentration inside the cell. So the ECF, it also has, doesn't have very much potassium, doesn't have very much calcium, magnesium, has a little bit of bicarbonate ion, but it also has a lot of here, chloride. So chloride is at a high concentration here. We also have in the blood, we have proteins that stay in the blood. And we talked about that. That would be like albumin, which stays in the blood, which is a negative charge, which keeps your osmotic concentration of your blood high so that water can be sucked back into the capillaries. So that's my ECF. And so then I can compare that to my IF, which has much higher potassium levels, has much higher magnesium. It has much higher phosphate, hydrogen phosphate, much higher sulfate. So we will talk about, or maybe you remember us talking about the nervous system and how like the movement of sodium, chloride, and potassium are what creates this concentration gradient. So like, for example, if I'm looking at the inside of a neuron, so this would be like in the neuron, a cell that is in the nervous system and produces neurotransmitters. When I look at the ECF, I say that sodium is much higher outside than it is inside. Right, so sodium is much higher outside than it is inside. And that is important because when I open up channels, what's going to happen is that sodium is going to diffuse passively from a higher concentration to a lower concentration. So that is a definition of diffusion, of passive diffusion. And likewise, I can put a big K on the inside of my IF, right, or my intracellular, and a little k here. And so potassium is going to diffuse out. So the relative concentrations of these ions are important in your body, not just for your nervous system, but also for your muscles. So like calcium regulates muscle contraction and other things we can talk about. But this is just looking at electrolytes. And if these are not balanced correctly, then the cells in the body can't function properly. And specifically the nervous and the muscular systems are two of those systems that rely upon these significant electrolytes.